All right, good morning, everybody. My name is Ben Partita. I think everybody here is
Hello.
a long-time member, so I think everybody knows everybody. Let's start. Today we have Jim, who's going to give us a talk on Alexa skills, and Alan following up with some more LLM stuff. So it should be fun. When you're ready, Jim.
All right. Yeah, video isn't working, but I guess I'm on camera anyway.
It looks like,
I mean, I
I don't think you're on the Zoom yet.
Cooper is.
no, I'm Cooper, yeah,
Oh,
but, yeah, I got it hooked up to this, virtual camera, and my real camera's kind of disabled or something. Technical stuff, anyway, it's mostly, sharing screen and like, really share screen. So today, start with my talk today is about Alexa skills and using them for your robot to give it commands and ask it questions, get status information. And so I worked feverishly on this the past few weeks and to get it working. Yesterday really kind of fully works. But the idea is that wanted to have a remote control of my robot that was not, from somewhere, so you could say, come to the office or find me in the kitchen, when the robot isn't there and is out of range of audio of your speech. So that seemed like a good feature to have, and a choice might have been to implement something on your an Android to write an Android app. That was my other choice. That would connect, take your speech, convert it to text, and then send the text and have a server on the robot and do a direct connect. But I figured, well, I saw this old article in a Servo magazine. They send out an email every month with articles from their past, essentially. And I saw this one, like, I got to do that. I put it on my list. And this article is like from 2017 or something, and it's kind of out of date. There's this guy who did it, and with his robot, and I tried to follow his instructions and didn't get very far with that part. Or he didn't go into detail. He just kind of said, go to the Alexa website and read. But yeah, I decided rather than try the Android way, which would probably take me longer to create an Android app and get all that, although I have a little experience. Sorry, Alexa's listening. So I decided, well, I kind of wanted to do an Alexa skill. So I figured this is maybe it's even easier. And it turns out there's a lot of information, and of course there's a lot of people doing this. So that led me to another article I found on the more recent article, although it does say it's like deprecated, partly deprecated, but so this was built-in Alexa control robot with AWS RoboMaker. So the RoboMaker is some simulator. That one is deprecated, but the rest of this article led me in the right direction to create an Alexa skill that can communicate with your robot, which, as I suspected when I first read some Alexa stuff, it's an IoT device. It's kind of fits into the realm of the Internet of Things. It's a thing in your house. And so AWS, so this is a combination of the Alexa system, the Alexa skill building, which is this thing, the whole Alexa skills kit, and AWS, which is the Amazon's cloud services. And specifically, the cloud service of IoT thing is what ended up being, this article gave me the framework, and I had to pursue it a bit more than the data and the information in here, but this was definitely the seed that got me going. And yeah, here's the diagram of what kind of goes on. Hopefully that's big enough. The user will say, Alexa, ask robot to move forward. Goes into the Echo, which could be on your phone or in a standard Amazon Echo on your desk or wherever it is in your house. And then it goes up to the cloud to the Alexa skill handler, which then you set up these things called intents, and there's a whole web page, and there's lots of docs, but there's a whole web building web page builder app that you can build the skill. You put in these different verbal intents. It isn't just like you can capture the text. It's not as simple as just capturing the text somebody says and send it. They don't really support that because that's not really their business model or their kind of main model of sort of execution. They want to handle that. Their clients will have specific skills, a specific verbal intents to activate, like Alexa, tell the Roomba to start cleaning. Hopefully it's not going to start, not a Roomba. And so I figured, because I've had a Roomba for a while, Roomba vacuum, robot vacuum, and I've been using this feature for a few years now, where I'll say that to start cleaning, and I'll say, oh, tell Mr. Toodles, his name is Mr. Toodles, I gave him a silly name, and so Alexa will say, oh, okay, I'll say, tell Roomba, you have to say tell Roomba to start cleaning because it doesn't say your specific name. And then Alexa will say, okay, I'll tell Mr. Toodles to start cleaning. And then Mr. Toodles backs up and starts cleaning. And you can give commands like that. And you could say, oh, you'll get a message, Mr. Toodles is stuck. And then you'll say, Alexa, where is Mr. Toodles? And then you'll hear Mr. Toodles beeping. Alexa will say, oh, I'll tell him to beep. And so this is a robot, and that's a feature. And so I'm like, I want to do that. That's what I want to do, something like that. And so yeah, so you have a skill set up in this cloud, and then the AWS. So for AWS services, you get an account, and you create what's called an Alexa a Lambda. Well, Lambda. It's an Alexa Lambda, so it's a specific one, and that when you use the building skill, or when you go through this web site or web portal to build your skill, it will take you right to the Lambda editor, or to an editor, and it sets up your Lambda for you. You can then edit the code right there, and you don't have to do a generic you don't have to learn, you don't have to do that part of it in AWS directly. So it's kind of made it a little bit easier for you. And then what you do is, the other part was a little harder. You want to then set up a way to send messages. And so that's what the IoT does. And that's, you can set up, we're going to see is I'm using MQTT, which is a message queue transport system, and that's how. And you have topics where you send messages or receive messages, and this thing called MQTT. There's some other people in the homebrew robotics that use that. Scott Monahan uses it, I think. MQTT is a well supported. It's the first time I've used it. I've heard of it, but you can download code from GitHub, get it running on your device fairly quickly. Your device just has to have some level of support: Windows, Linux, Mac, maybe even smaller devices. But there's it has to be able to run this code. It has to have an IP connection and things like that. So microcontrollers, I don't think so, but you need a little bit of elevated from there. But it is designed for things, IoT things, so it's a fairly low bar. But you get that, you have a client running on your thing, and that can receive and send these messages, and then you have the cloud that will also send and receive. So forget about this AWS RoboMaker, I'm not using that, but that's a simulator. So it's really just this, and then your robot is at the other end is the, this actually looks like orange a little bit, except it's not orange. So then the robot will receive messages. So that's sort of that's how it works. And then the robot can send messages back up to the cloud, so you can do queries. And that's what so I've set up a demo for queries and commands. So onto the, so there's a lot of, there's, this is essentially free for, the Alexa skill part can be free, like most, like I think there's, the free tier on that is pretty widespread, but in the one that's not permanently free, I think, is this AWS IoT stuff that I'm getting into. The Lambda, I think, that's like 1 million, you can have 1 million uses or something for free. The IoT one is a 12-month free, and I've only, in all my work in the last few weeks, I've used like less than 1% of my free usage. So
it's not calendar 12 months, it's like how much you.
It's from, no, that part is a calendar from when you joined, but I don't know what the cost is after that anyway. It might be, and that's just for the IoT thing part of it, not the Alexa part.
Mm-hmm.
So I'll have to see what they charge, but.
And there's other options. If you run out of that, there's other free options for MQTT servers. If you're like doing low bandwidth private stuff, there's other options.
Yeah. Now the other benefit, yeah, okay, good. Yeah, thank you. The other good thing about MQTT is it's a secure channel. It's a secure form of communication, and I have to set policy. I have to get public and private keys and all that stuff, and so nobody can really send commands to your robot very easily because it's encrypted, and it's secure, which is neat. Which I would have had to implement. If I implemented that myself, it would have taken a lot longer. So it's so yeah. And before so let me just do a quick demo. I thought I'd do a demo at the beginning here, so you know what's going on. In fact, I guess I'm going to do it on the screen here, because it'll be a bit, you'll be able to see stuff. So right here's my my developer console. We'll go through part of that, or we'll go through some of the steps in there later. And this is the test, which is a great place to test your thing. Now, right now, I can use the real Alexa as well, but this is essentially a way you can see it. So let's try something here. Ask Big Orange to what is his status. Oh, I don't have audio. Could you repeat that?
I'm not sure. You can ask Big Orange questions or tell him to do something.
That's the regular Alexa. Ask Big Orange to give his status.
I'm not sure. You can ask Big Orange questions or tell him to do something.
Ask Big Orange what is his status.
I'm not sure. You can ask Big Orange questions or tell him to do something.
So maybe address Big Orange.
ask Big Orange, what is his status?
Big Orange is located at the home and his battery is at 88%.
One thing I learned about this is you have to hold the microphone down to you're completely done speaking, like a little late, because otherwise you lose a word. So this is sending up a query and getting back a response. Let's give it a command here that will eventually bring it. I'll have it move, but we can do something else. Ask Big Orange to take a picture.
Okay, Big Orange took a picture. It will be shown on his screen.
So does that work? So,
It's in the hallway?
yeah, it's in the hallway. Yeah, so we can actually, I can have, if no people are paying attention here, tell Big Orange to come to the meeting room.
Okay, I've asked Big Orange to go to the meeting room.
Oh, great.
Here he comes. This is sort of the thing I've been, this was my vision a few weeks ago or whatever, or well, probably longer than that to get. I guess I could get on Zoom here and to show you coming.
So you mapped this area during a previous meeting? Or
Yeah, I mapped it previous and then I just updated it for the part that was, so I loaded a map made in like June or made of like March of 2022.
Nice.
Here it comes.
Oh, you've got the.
Here he comes.
Wow.
Yay! You're almost there. Yeah.
There you
I'm not.
go. You have arrived.
So that's, I like to throw in, I'm wanting to throw in demos early in the talk to give some satisfaction to people. Then you can like decide whether you want to, pay attention to the rest of it. But yeah, so, and yeah, you can even tell them, well, I'll let them sit here for a while, then we can tell them to go recharge, so that works, or go to home, leave the room. So that's your test area. So let's go back this is the kind of, this Alexa developer documentation is where I really got going with, and it tells you, here's some more diagrammatic stuff going on here. So yeah, you've got the person speaks, it goes to the service, it does all of that automated speech recognition for you, and then it goes to your skill. And so this part is the normal, just the Alexa part. I had to find that article and figure out how do you do a robot from that. And that's where the MQTT stuff idea came in, and that, well, I guess I didn't show you the full article, but this guy says here, create an IoT thing in AWS, IoT, create an Alexa skill, forget about this part, I didn't do that. And so these two things got me going, and to be able, and then he does, I think this is where I also got the idea for MQTT, add IoT MQTT intent handler to your Lambda function. So through this article, it was like most of what I needed conceptually. And so then I moved, then I heavily used the Alexa developer documentation, and it takes you through all the pieces you need to do to, well, you can just go down this list here. Design your skill, build your skill, test and debug, and that's as far as I've gone. I'm not certifying and publishing anything, but these things are the critical things you need to design, build, and test and debug. And you do that. So there's two halves of this, really. There's the Alexa skill side, and then there's the IoT core, IoT thing side, which is part of AWS. So start with the Alexa skill side. So I have this, I'm on the developer console here, and you can see here is a big orange robot. Right there's my only skill. And you can, so then you click on it, and this will bring you to the design page, essentially, for designing and building your skill. And now there's a few just main pieces of this. The invocation name, big orange. So it has to be 2 words. There's certain requirements you have to meet, but 2 words, you need 2 words. And this is how you will ask Alexa to send commands or interact with your skill. So you'd say, tell big orange. Oops. He picked up something. I can tell him that. He doesn't pick up much because it has to trigger that wait word detector. So that's simple. And then I haven't used this part isn't enabled for my skill. So it's just you just have to have, and yeah, you can also say things like open, then your skill name, and then you can have sort of an interaction. You probably might have seen that. I haven't used that. I haven't tried that myself yet. But instead of, you could say open, you could say, open big orange, and then you could say, just give it commands like, what's your status, or go to the blah, instead of having to ask it. Yeah, it's a little, I'll try that next. I didn't have time. So the next big thing is the interaction model, and that's sort of the core of your skill. And so the first thing you have is intents, and you get some automatically from Amazon: cancel, help, stop. These are things related to that when you open or cancel, that you can cancel and close it or stop. It doesn't mean stop the robot. I had to add my own stop the robot. Now these are the ones I added: status intent, go to intent, take picture intent, recharge intent, where are you intent, stop all movement intent. So these are the ones I added, and like for instance, status intent. These, you give it some sample of what it might say, and this is just like the part after the invocation. So it would be, ask big orange his status type, and then you make this into a variable. It's called a slot, actually. So this is a slot, like a variable, and you can make as many of those as you want. And this is the name of it, and this is the type. So then you make slot types to whenever you want to capture something that you're giving a command or during your verbal interaction. You use a slot, and the same thing with the go to intent. Come to, you just saw me use this one. Come to the location. Oh hey, Nick. And then find me in the. I haven't implemented this one yet, but meet me in the location. Well, all these actually will do the same thing. They'll just go there. So you won't actually. I haven't added the find part yet, which is in orange. It's in, he can find a person, but and maybe even me, because he has my face, but that would be a little extra work. And I might have to make technically I may have to make a new intent for that, because all of these are really under the same intent, go to intent, which, and now I might be able to make a sort of a sub case of the intent, but when these are processed, it's going to just give a go-to command to the orange, and so that's and then you can see that those are the different examples, and then like location, so that's, and then take picture intent. This one is just like some verbal commands, capture the scene, snap a picture, take a picture. There's no slots there. It's just a straight command. Recharge intent is the same thing. Go to doc, recharge. So these are just commands. And then where are you? Same thing, that's just a straight command. Stop all movement, straight command. So there's no intents there. So these are much simpler ones to implement. And then, yeah, like I said, you get these built-in ones, and in your code, you can do things. Some of the code for this is already given to you. No problem. And yeah, so you saw, okay, now the slot types. So I guess I didn't show you, but I am using in the go-to intent. Let's see it here. Go-to intent is using location. Okay, location, it's too small to see here, but location is an Amazon.room. Okay, so I found that they happen to have a slot type called room, and I added a few to that. So Amazon.room is Amazon's database of things that are names of rooms. So I don't have to implement that myself, which is great. So you could tell it to go to, Big Orange, go to the arena, or go to the parlor, or the sun deck or something, and it will say, I don't know how to get there, but Amazon Room takes care of all that, so I don't have to put every value. But there are a couple values that I know that I don't know if Amazon Room has, that my robot has in my house. So I added those as extras. Like
Yes.
Which is kind of a weird
Yes. So.
front door, which isn't really a room, but it's a location. So you can add on to that. So that's a nice, that's a feature of Amazon having their own slot types. Now back to where was I? Right, so those are the intents, the slot types, and then right, for status, for instance, the status type, slot type, status type, we have location, battery level, and status. So those are the ones that I'm allowing for now. So that's kind of what you can ask it. And the room one is used for where you just want it to go to, right? So any questions so far about this before I move on to the wonderful code section? So this part is all you use the web page to do all the work, and it's fairly straightforward to. It's a GUI that you can use. The next stage is now into coding, and specifically the Lambda function that goes with this Alexa skill. And what's a little background, I just learned about Lambdas. Well, I had heard about them in the past. AWS is this amazing set of cloud services, okay, from Amazon. You can do all sorts of things with, including IoT and running whole 24/7 servers, et cetera, et cetera. Lambda is this special service that is a temporary spin up, spin down, or just a very, very quick, quick and dirty operations, and you get charged very little. In this case, you get, there's a huge free tier, but even when you're a professional using Lambda, it's minimal. It's kind of like you you do some query, and then it spins up the Lambda function, does its little work, and then closes down. And so it's a cloud service that is very short and very inexpensive. And the code is very short. The code is also not very long. This whole file is, well, obviously your file can be as long as you need, but it's not very big to do what I'm doing here.
And it's serverless, so you don't have to worry about putting a server up, keeping the server maintained.
Right,
These
and
things just, it finds the server for you, you don't worry about all that stuff.
yeah, and this, well, what you do in, like, if you're doing if you're doing more generic AWS, you have to spin up a server.
Yeah,
and
you
get
gotta
a,
make
get
sure
a,
it's secured and up to date, and is this on the right port? And
Yeah.
This just does all
we have
that
to have a
stuff for you.
Docker, you have to have Docker things and
Mhm.
launch it. So this just uses a machine that's already, it's a Linux machine, typically, and it will, and all you have to, like, this directory here shows you, I mean, this is getting into it also, you can do Python, or you can do other languages as well. Node.js is a big one. I don't use Node.js, so I'm a Python guy, and then, if you add new, dependencies, like I had to add this one here, I guess, I didn't have to add, no, and this one, so when you build an Alexa skill, it automatically creates a Lambda function, for you when you choose, like, sort of what kind of, skill you want. And if you can choose Python, and I want a Python hello world, and so it will just fill up this, it'll fill up this, file here, Lambda function with a hello world, and then from there you can, and it'll automatically work. It'll be able to say things. It'll be able to handle hello, and also when you make that Alexa skill, it starts out with a few hello things in there, so you can immediately just start saying hello, and it will go into this. It runs this code and sends back a response. Yeah.
So if you told it to go to the kitchen, I forgot what you called it, the kitchen nook or something, kitchen corner,
Right.
would he literally start heading to your house, or would it be like, no, I'm in a different?
No, right now, like, let's try it, let's do it, because I know all about instant skills, or about what I usually test up. I'll go back to test. Ask Big Orange to go to the kitchen nook.
Sorry, Big Orange does not know how to get to the kitchen nook.
So for the go-to skill, I actually do have a response. I figured, you always have to have interaction. So when you ask it to go somewhere, it actually looks at its current location. On the robot side, it looks at its current location list, which I've loaded the CalSpace map and locations. So it only has two, home and meeting room. And it says there's no coordinate, just like one line of code tries to look up the coordinates of kitchen nook. It says there isn't any, and then it sends back an error. And so yeah, that's like kind of that's something you can do. So I have this back and forth between the robot and the AWS.
So when you get home, you reload it with your home.
Yeah, when I look, so one of the prerequisites is when you get to a location, you boot up Orange, you have to say load map of the place. I don't have any way to there's no way I have a way to automatically do that. So you tell it to load map Cal State or load map my house. Now I could have it automatically load map my house when I'm at home, but I prefer because I might forget, so I just make myself load it every time. And so yeah, that's how that works. But back to the code, so that and well, actually, before I get to the code, I guess because looking at code is kind of tedious, you can see more diagrams. And now I'll move to the AWS side. We'll get back to the code specifically. So on the AWS side, so in that code is where things get married. In the Alexa handlers are combined with the communication with MQTT. That's all done through here. Or I was just showing you, if you're a Python guy, if you're a Python user, you might recognize this requirements.txt is what you need to run your Python your Python module, say, in this directory. And so I I had to add this last one, AWS IoT SDK, which we'll talk about. That's the one that is for IoT communication. The other two here came with the hello world, because you need the ASK SDK core is the Alexa core. That's what we just were showing here. It's the Alexa Skills Kit. So that when you make it, you're going to be using that. So that's there. And then utils is already there too. I think they give you these utils. And then you can add files here. Oh, the other important thing here to mention is the certificates. So I had to create these certificates, the public and private keys. And this one is, you needed a certificate for actually accessing the Amazon AWS. I think this is to communicate to your AWS server side. And so this is what makes it secure. And they show you how to create these keys. It's fairly straightforward. But this is the, without these, you cannot communicate. It will just hang up on you. And you also have to configure what's called a policy as well. So getting started, so AWS is a lot of stuff going on here. And we're going to just focus on one part of it. But there's a whole free tier, and yeah, you can read about the different types and the costs and stuff. And it's like there's a big free tier, which I'll show you right here. Actually, I have it set up. You know, you get this 12 months free for a lot of different subparts of AWS. And then there's an always free tier as well. So I've highlighted both of those. Like some of them you get 12 months free, and other ones it's always free. Like AWS Lambda, the one I'm using, 1 million free requests per month. I don't think I'm going to hit that anytime soon. So that's free. The one that's not, the one I have, the IoT one is free 12 months. That's this one. And so I'm also using AWS IoT Core, and you get 500,000 over 12 months. And you can see I've used less than 1% of this in the past few weeks with all my testing. And then after that, I don't know. It's probably pretty cheap, so I'm not going to worry about it. I'll probably have moved on to other. And I might be using this device management or otherwise monitor. Oh, not at scale, but I'd probably move on to another project before year is up. And so then, okay, so then you log in and you have the AWS IoT. That's the thing I'm using, where you have things. And here's the little diagram again. Securely connect into individual devices, and then, yeah, you can test and you can manage these different devices. And well, I guess here's a nice little interactive tutorial. Oh, it logged me out. Even just for the tutorial, I have to do. Yeah, you can see, again, this is similar to our other diagram. So you, from your, connecting to an IoT device. So now we're getting more specifically from into an IoT device. The other was Alexa, an Alexa diagram for just using Alexa's skill. Now, what I'm doing is, this is the IoT side of it, and Alexa's going to feed in here. So it would really be Alexa feeds in, and it connects to this secondary cloud service. And then that cloud service goes down to your specific device, your Internet of Things device, your thing, we call it, and that can be a robot. So here we can see this little animation. You do some kind of command, it goes to the cloud, and then from the cloud, it goes to your device, turns on a light in this case. In my case, it's executing a command on a robot. This is a thing called the message broker. This is more specific stuff, but essentially, A device gateway sends a message to a message broker that's in the cloud, and the broker sends the message to subscriber. So what's also cool about this is there's no IP connection. There's no direct connection to your device through your firewall or anything like that. Your device is making its connection to a server. So that's why I can bring it here. I didn't have to do anything. As long as I connect my device to the internet, it's reaching up to subscribe to in the cloud, as opposed to like other projects I do. I have to like open a port, or like I have to expose something, a way for a direct connection into a device, which means you have to have a firewall exception and all that kind of jazz, right? If I want to connect to a computer that's inside of a network somewhere, you have to go through hoops. And I've done that at home, where your router, you have to open a port up, you have to forward ports and stuff like that. This whole model, they know that nobody does that. No normal consumer does that. That's only like IT people. So this technique is your IoT, your thing at home, it makes its connection to the cloud. Your Alexa makes its connection to the cloud. And so then it's up connection, not down. And nobody has to try to get through a firewall. Most firewalls, going up is no problem, right? It's only that's how you have internet access. But trying to make a connection into something requires all sorts of security exceptions. So that's another benefit of this. And again, it gets into some other things like offline state. I'm not implementing that. So okay, that's the tutorial. Now, now we can see. We also can test the client from here. Subscribe to a topic, publish to a topic. So like I can subscribe to the same topics that orange is. And for instance, there's a command topic and a response topic. So if I can actually say publish to a topic here, normally they use JSON, but I don't. So I can say, I can give orange command here even if I typed in command topic. And then I could, but I don't know, let's see, I don't know if this, then I could subscribe as well. So if I subscribe to the response topic here, subscribe to that, and then if I publish to the command topic, let's say location, let's see what that is. Away from me. What does it say? So it worked. Big Orange is located at the meeting room. So from this test system here, or this MQTT, now we're into MQTT. So from here you can send commands. You can do and you can test things at the sort of, this is the back end now, this is the IoT server. So I'm going right from that. See, Alexa, you have, I'm holding my hand up. You have an Alexa server, you have IoT server. When you talk to Alexa, it goes to the Alexa server talks to the IoT server, and the IoT server talks to the device. So now I'm cutting out the Alexa part, I'm on the IoT server talking directly to, sending messages to my device. So that's, and then, okay, all devices thing. So here's where Big Orange is, the Big Orange thing. They call it a thing, it's an Internet of Thing. So a thing means something connected to the internet. Could be a light bulb, could be a whole robot. And so I set this up, and you can see, this is where you get certificates. You have to create, this is where I got all the security, and the certificates come from this setup here, and they walk you through it. It's fairly easy. I'm only using a fraction of the capabilities of all this. It's, I can now write up a document that could take you through this. If you want to do it specifically what I'm doing to your robot, then I have all the information that you'd need. And what else is going to show? Yeah, so that's where attribute, device activity. That's the test client. The other thing is, there's security. So this is an important part that I didn't know. I was getting hangups all over the place, and I realized that there is this policy document that you have to specifically allow things to go through. And you have to specifically create the topics where you're allowed to publish and subscribe, etc. So here's like I guess the easier to see version instead of the JSON. But so I've added the.
This is the Renaissance fair.
Okay.
So you can see here I have allow publishing on the command topic and response topic. So I had to add just these words in here. This other stuff is I just copied. By the way, yes, you are running servers in different places, like at the US West. At first I was doing it in Ireland because there was a bug, and apparently I tried to create an Alexa skill, and it says I can't create it. Sorry, try again. I'm like, that's it? Try again? And I tried again like 8 times over a day, and it just kept saying this just one line. So I got to Alexa support, and they go, yeah, there's some work going on in that Northern Virginia one. Can you just use the Ireland one? Because Ireland was like another choice there. They had Northern Virginia and Ireland. It's like, okay, well, and then they said, well, you can change it later. So I created with Ireland, and then it worked. And then later I just changed it back to Northern Virginia or US, and then for the Alexa one. And then this one, the IoT one, is in Northern Virginia. So you kind of have to keep it straight. But you don't have to worry about that too much. It's just like, you just have to remember, like, where is my thing? Oh, if you click the wrong one, then you won't find your thing. So that was kind of funny, like that Ireland got involved. So I was going through Ireland to control my robot at home. Sounds like something out of the Big Bang Theory, where they control a light bulb going through like a satellite or something. Anyway, but yeah, so a lot of these were already there. So I added a command topic, and then here's receive. So command topic, response topic, I added receive on those two. And then publish, retain, I don't know. That's like, I think that automatically got added when I added the other ones. So I think that one will publish, even if your device is down, like unreachable, when it comes online, this will automatically send it if you specify. There's also a thing called quality of service, which I'll maybe touch on if I need to move on here. And then the clients, you need to specify, like Big Orange Robot. I have to specify the client name, and that's what Big Orange says he is. That he identifies himself as Big Orange Robot, and I allow connections. And then the this thing, the actual the lambda thing actually uses this identity, SDK Node.js. That just someone that was there. I didn't have to do anything, because it comes with the hello world code again. And then, like you can see, I have different versions of this policy. I had to keep changing it. So that's how that's how you give it permission. And then there's different metrics. You can look at things going on your successful connections, messages published, all this kind of stuff. So that's the biggest thing here is when you make a new thing and you go through you go through this whole set of steps where you give it the name, you give it the type, and then you'll eventually get to getting the security for it and all that. So that's the AWS side. Any questions about that? I know I'm probably missing something here, but yeah, that intro certificates. Yeah, so that's the rundown of how you create a device. And here, this is how you start. You just say connect device, and this will help you go through about 15 minutes. You can register a device and then watch it send MQTT messages to IoT. So that's essentially what I did. Oh, here's another nice diagram. Funny, going bigger makes it smaller. So IoT devices connect to the AWS IoT and then connect to different services. And there is Lambda. So that's where I'm keying in. We're going to go back to the code now. Let's see. GitHub. So this is the, in Python, you use this AWS IoT device SDK. So there's instructions on how to install that and put it into your device. And so it's the same thing. It's called AWS IoT SDK. So I just took some sample code and manipulated it and put that on my robot. So that's running under Windows in the Python environment. And here's this is some of the this is the help document about how it works. And we won't go too much into that, but this was about the costs in the free tier. You can look again. There's a lot of info, but I don't think I'm worried too much about getting any costs associated. But back to the code briefly. So I created a class called the AWS MQTT Publisher, and so essentially what it does is it connects to this. So this is the Lambda. So when you say something from an Alexa, okay, it goes through these things called handlers. So this code here some of this code came with the what do you call it, the hello world, right? So like this one, help intent handler. So that one's like one that comes with every, remember back here with the, back in my, I guess I have to switch that. Back where I was back in the build stage, there were those different intents you saw. The help intent is one where you ask Alexa for help, like what can I do, and then I say you can ask Big Orange for status information during commands. To do an actual command, you saw those intents I had. Remember earlier I showed you status intent and I showed you go-to intent. So this is where it actually gets handled. When you say ask Big Orange to go to something, Alexa then eventually spins up your Lambda and then it creates this, you install these classes, these handlers here. This is again all sample, a lot of this comes up as sample code and you just add to it. And so what happens then is this handler, you check to make sure that it is the go-to intent. This is the real name of the string name of the go-to intent. This just makes sure that it's got to the right place. And then the critical code here is, I want to get the location. Where is the person asking the robot to go? So I say get slot value location. And then, and now this is the critical piece of code that sends the command. Publish command go to location that is inserted here as a string. And then the last critical piece is speak output. Publisher wait for response. So this waits for a response from the robot. And if it doesn't respond in time, it will say something generic like, well, I put it in. like, try again later, you know? That's right, publish command,
Yeah.
And then when the vowels came, it just both sort of.
so here's wait for response. So if 5 seconds goes by, I say, I'm not sure what happened, try again. You know, I'm trying, so anyway, so that's, and the other ones are simpler, like, just to stop all movement, it just sends a stop all movement command, and then it gets a response. I pretty much always get a response from the robot, because I want to see, I want some kind of response. And then, well, if you want to connect to the other side, to the robot side, let me see if I can. Hey, Orange, open your eyes. There is, and then it's like 11:46. So we connect. Let's see, 11:46. See if this works. Or are we?
Well, it did it. We got a warning message about the certificate. Oh, saw it. Oh, then.
This is always a little dicey at the Cal State where I'm using the internet.
Oh, maybe that's not the certificate.
One 192.168.11.
Confirm.
That's the right one. Good. Or maybe that, yeah, that would be it, right? You guys use 192.0.
That's,
Is everyone on the same network?
Yeah, that's not ours.
that's the real cool.
No, that's not mine. That's
not ours.
it's not yours.
Only 2.168 is.
Well, Orange is connected to the network.
That's a local class C, buddy.
Good point.
Hey, you're,
You're probably Timm that.
well, what is your,
Let me take a quick look.
1039?
Yeah,
Oh,
you got a
so-
hotspot or something. Are you to your phone maybe?
No. I logged him into the Cal State network. He's probably showing the wrong IP address. Where did that IP address?
That's the difference.
Maybe that's your old one from home.
Yeah, that's the home.
I don't use 11, I use 192.168.1.
Baseline posting.
The one, only even that one, that's the.
It's more of an
Yeah, local.
Yeah.
Network.
Hey, Orange, close your eyes. Oh, I have a keyboard. Maybe, all right, there it is, 1039, 122.36.
No.
And 39,
132,
132.
about 36.
What wasn't it, 122?
I thought it was 29.
I thought that's what I heard you say.
Hold on.
Oh, darn it. Sorry, I steered you wrong.
122.36.
Yeah, there's two networks, obviously, there's, multiple IP addresses, and it was looking at the wrong, well, here you can see, this is a little IT primer here. It was using the Ethernet adapter, not the wireless. So that's my bugging in my display of the IP address. I guess I'll have to
See which one's active and then display that.
find how to do, that's a little bit of extra code. There's always a corner case. Oh, and I probably messed up, I probably messed up Orange. I'll have to restart him, but this is funny when you connect, that's it. Or, it's okay, because I was gonna have him go back somewhere. Anyway, but, so on this side, this is, what is this? Oh, I'm in the wrong directory. Let's go to the recent. So here, I need to open the notes. So, looking for the MQTT thing, where is it? Oh, I'm in the wrong place. Go to the, okay, should be recent. Oh, good. This. Let me just put it away there. Oh, am I in the wrong, I'm sorry, I'm in the wrong computer here. Jeez. It's kind of messy. That's why I'm getting confused, because I wasn't opening the right computer. Here we go. So, is it control plus? So here is the MQTT listener. So on the robot side. So here I created MQTT listener. Remember the other one was publisher. So this is listener, and it's set up the same security, and then here essentially I connect and then subscribe. I subscribe to the command topic, and I send on the response topic. So this is subscribing, and then when I get a command, I then handle them right here. These are all the handlers. This is the handling. Yeah, this is it. This will tell you like Big Orange battery is at blah, and so then this calls back into the Big Orange code to get this information, and then this sends it back. This publishes. So then publish response is right there, and then here is a publishing response. And this is the other thing, this quality of service thing is very important. Most of these servers, in fact, here's a little doc on it. The quality of service is the message is delivered according to the capabilities of the underlying network. No response is sent by the receiver, and no retry is performed by the sender. This message arrives at the receiver either once or not at all. So they have at most once, at least once, and then there's one called exactly once. And guess what? The exactly once, you say, oh, why don't I just choose exactly once? That's what I want. It's like the servers don't support that. That's too high of a quality of service. This is sort of more like the UDP days, you know, or I don't know if you remember, UDP was just like send a message out in the internet and hope that it gets received, and it's non-secure, not like TCP or it's an actual connection. But in any case, this is how these type of things work. And I didn't, you know, I was noticing at one point where 2 messages came, and I'm like, I don't want 2 coming in of the same thing, because then I have to have redundancy logic to figure out. So I'm like, I'd prefer at this stage of this quick demo or whatever, quick effort, at most once. So if it doesn't hear you, you just tell it again, you know, that's normal. So I'm using at most once. So I don't have to worry about the same command coming twice and it not actually being 2 times that you want, right? You only want once. So anyway, yeah, so this is
on the like the messages being received and everything, but they're queued up, they're sent to a queue, and then you suck them off of the queue, right? Is there some sort of timeout? Like if I send, you have it configured so they time out if you like send a message now and you turn your robot on tomorrow, you don't want it to probably grab that message again, right?
Yeah, well, in this case, I don't have it set up to do storage. So the message goes out, and if it doesn't get received, it's gone. It's not. I don't think these. If you're not subscribed, in this case, it just doesn't. Just the message is thrown away. I think you can set that up if you want that. I think that's not.
That's better. What you're saying is better.
I mean, that's a feature, I guess, one of their features, but yeah, I don't think I have that on, at least I haven't. Yeah,
Like you said, like UDP, you fire it out there,
yeah,
it gets there or doesn't.
yeah, exactly, and it's like whoever's subscribed gets it. If you're not subscribed, you don't get it, unless you enable that extra stuff with the storage and so that it will keep it, and if such and such a robot isn't subscribed, then but there is something like if you're subscribed and you go down briefly, then when you come back, it can still be there, or something like that. Anyway, so that's the side of the robot side. So it's very similar to the Lambda side. And let's. I wonder if I broke. I might have broken the range, but let's see. Let's go back and try to get another command. As long as I don't have to scroll off. If you scroll off that, the robot doesn't do anything. A printf can stop your robot. Ask Big Orange, what is his battery level?
Big Orange's battery is at 50%.
Oh. I don't know if that's real. Oh, my battery thing. I'll have to ask the experts, but I think my battery is dying. It's been a few years old.
That kind of drop.
Yeah, it's going all over. I think my logic for my circuit and circuit I have a voltage divider and this type of thing, and I think I'm not getting good values anymore. But and the battery chemistry has changed over time, and it's now got a different curve than I had initially set up for the. Yeah,
Was it that acid?
No, it's
okay.
it's liquid.
Okay, then it should be fine. You just typically have your drops happen much faster.
That's what's happening. It's going all over the place. It has to go back to the recharger a lot.
Yeah, that's probably not.
Tell Big Orange to go recharge.
Okay,
I'm going to the
I've
recharge
asked Big
station.
Orange to go recharge.
Right, the audio is coming through here now.
I've arrived.
Oh.
Oh.
Tell Big Orange to go home, go to the home.
I'm
Okay,
going to the
I've
home.
asked Big Orange to go to the home.
Sorry, I didn't make it to the home.
I might have kind of wrecked things by logging into it. But of course you can, yeah, I can restart that. Yeah, see, the battery is just like all over the place, and like I have a sort of a curve that sort of relates the voltage to percentage, and I created that curve based on these little lights on the battery a few years ago, and I think that it's changed or something. I'm not the greatest with that kind of.
Test the capacitance of the battery.
Yeah, I mean,
See what you still
it
got.
might be just time to get a new one or a
Yeah.
better one, because I've got a lot more power requirements now with 2 OD cameras, a few amps each.
Yeah, because sometimes when you see the battery voltage percentage on here change like that, it may just be load.
Yeah, it is load,
When
yeah.
the battery gets old, they can't supply that current very well, so the voltage a bit more.
So it's the oldness makes it not able to provide the current. And so then the voltage drops, and I'm getting brownouts of my CPU.
I'm starting up.
So like I use the remote control and rev the motors, and the computer went
Hello,
down.
my name is Orange.
It never used to do
Pleased to
that.
be at your service.
Oh, let's try a picture then. Of course, it's not gonna know how to go home now, because but let me try it from here then. It's really the best. Actually, that's it. Oh, yeah, that's it. Yeah, that's it. Alexa, ask Big Orange to take a picture. There you go. So yeah, there's a lot of of potential for this. I don't know how much further I'll go, but we'll see if I get useful features. But the go-to and the status things, those are kind of your basic requirements. From there, it's a matter of you could add more intents and all sorts of features. Come find me, so it like actually comes to the room and then looks for you as well, which I've already have that. Orange can already find a person in the room, and it can identify a person's face. So you have it's hooking up these features to like cloud service and being able to do it. And this saves me the trouble of having to implement an Android app or whatever. This is, by the way, what it looks like from the sort of the log. You can see that. It receives a command from command topic, take a picture, handling command, and then okay, Big Orange took a picture. So this is sort of like the robot, a little capture of what happened. So that's it. Any questions?
Yeah, so you've got like 2 ways to get voice to your robot. You've got voice recognition on the platform itself, right? And then you've got this. You kind of keep them both, or just experimenting around, or could you move Alexa to the main robot and use it for everything? What do you think the sweet spot is for that?
Yeah, that's a good question. I mean, I primarily added this so that you could talk to the robot from anywhere when you're not near it. And then when you're at the robot, I prefer to use its wake word detection, its local one, I guess. But yeah, then it's more privacy too. Like, I mean, obviously this is all encrypted, but like when you talk to Alexa, it's going to Alexa, it's going to the Amazon. So I don't need to involve them with, they have enough on me, you know, with my 3 of them at home or whatever, you know, so, but yeah, I kind of like local things normally, but in this case, the robot's down, you know, it's not here, therefore I don't have a choice. Either I use, you know, I figured this is a fairly easy entry to get into using their service. It's free, and I think it was a lot less work than if I implemented my own direct, like, Android app connection to my robot with voice. That would have taken longer than this. This is doing Alexa skill is, there's a lot of guides there and sample code, and it just, you know, it's not as hard as some other projects you might do where you just start with a blank, you know, just a piece of, like, you know, a code that someone gives you, and then you're like, I don't know, what do I do from here? It takes a long time. Whereas this is, I mean, this is at least getting you, like, this, what I did is a little bit advanced, because I had to piece together, you know, that multiple sort of cloud services and figure out, well, how do I even do it? I didn't even know about MQTT, but that one guy's article kind of set the, you know, gave me the info I needed. So yeah, any other questions? Great, well, thank you.
I think we're good. Thanks, guys.
Sorry, I went over, but, and,
That was impressive.
oh, thank you.
And with that, Alan, are you ready?
All right. Go ahead. Share my screen a little bit. All right. Wrong one. I'm sharing the main screen. It's not the wrong one to share. There we go. This makes more sense. Okay, so kind of how I wanted to approach this changed a couple times over the past week, and I decided to start off with a bit of a retrospective. Like 2 years ago in a month, Jim and I were digging about with an older model, GPT-J6B, a 6 billion parameter model. I, not being as smart as I look, implemented it the hard way using the instructions here, mesh transformer jacks. DLL having exact versions of Python and PyTorch, and if everything was set up just right, it worked. Jim and I recently, just after this, started using the HuggingFace repository. And like, these were really exciting times. GPT-2, GPT-3 were out and available. But to be able to run this model locally on high-end hardware or through Google Colab, just going through, sorry, grabbing the wrong mouse. All right, all the way, got this. Looking through like where we got started and some of the examples. These guys here. And about 1/3 to 1/2 of the time, you could get an interesting conversation out of it. And it was so cool that I would screenshot these and save them as text files. And it seemed like almost overnight, the Turing test, Alan Turing's proposal to determine intelligence in a machine, had been cracked, had been beat. Now, since then, a couple of things have come about that makes getting into using these models a lot easier. This talk is going to turn into a no-code talk. Everything that I'm going to show you are things that you can do and implement by locally through installing a really cool Swiss Army knife front end for these large language models called textgenerationui. I'll start pasting some of these into I'll place it in a bit. This makes it really easy for you to download and use and play with and understand how these large language models work. The second thing that came about a little bit before, and you've heard us talk about it a couple of times, is HuggingFace. HuggingFace is the central global hub to post and download large language models. Now, if anyone publishes a large language model, they're going to publish it to HuggingFace in a HuggingFace compatible format. And using their Python module transformers, it went from an arcane series of commands and writing your own chat interface to literally 3 lines to download, instantiate a model, and then to generate tokens for it. So between these two kind of breakthroughs, you can get into these and start using them without writing any code at all, and still be able to do lots of experiments to understand the capabilities and limitations of these large language models. Now, of course, just to start out with, you can, and I would highly recommend setting yourself up with a free ChatGPT account. Unless they get super busy, they're not going to kick you out. And I personally bounce back and forth between using ChatGPT and whatever local downloaded language model I have on my computer. But I found myself using it to almost pair program. I have my hands on a lot of stuff. I master of none. So over the past week, there was something I had to figure out in Microsoft SQL, the language used to query and use data on a server. And so you can always do a quick Google search with Stack Exchange to pretty much figure it out. So in this case, I'm like, hey, ChatGPT, remind me on how to do this pivot table technique using data in Microsoft SQL. And it absolutely worked through the details for me. It was great. So I'm like, I remember it's possible. How do I do it? ChatGPT fill in the blanks, and before you know it, I'm moving on to the next minor challenge for real world things that I'm doing here at work. Like even simple things like creating a temp table. Super helpful. So I'm already using this today. As you're probably aware, Walter, Ben, and I, we all work together here on campus, so we talk robot shop all the time. In addition, people in our department know this as well, so they'll hit us up with questions, things they read in the news or whatnot. And my buddy Cole just yesterday on Friday cornered me for a minute. He's like, "Hey, this ChatGPT thing, is this just a fad? Like, what's going on? Because you can't not go into the news and not hear something." And so the way I explained it to him, my understanding of it, of course, this is all tinted by Allen colored glasses, is what's happening right now is similar to when Apple released the iPhone or the first home computers came about, but on a much more contracted time scale. You've heard us bloviate about Dr. Werner Vinge and the coming singularity, which is the concept that there's a point in time beyond which we can't imagine because it's changing too quickly for us to figure it out. Trying to explain the 21st century to someone from the Stone Age, right? Like, how close would they get? The ChatGPT large language model thing is definitely not a fad. The technology is something that people are making real use of today. It's a transformative technology. And personally, I think we're at an inflection point where it's impossible to guess what society at large is going to look like 3 to 5 years down the line, just based on what it can do today. You know you've got something good when you have it in your hands, the smartest people on the planet are still trying to figure out its limitations, right? And in education, you know, they're struggling with the easy questions, like how do you educate students in a time where any student can use ChatGPT to write a paper on any subject that passes the plagiarism test, to really more insightful and more advanced uses. There was, I might have mentioned it a few months ago, there was a study in the 90s. Dr. Allen, someone on YouTube brought this up, so I'm happy to recant it, that was able to correlate the ability of a student to learn and take in information was inversely correlated to the number of students in the class. In other words, the larger the class, the less one-on-one time, the less opportunity for the student to excel. And that putting students into settings with less students per instructor or even one-on-one saw a marked improvement in their ability to learn. And so what that did was it took an average student and made them a good student. Took a good student, makes them a great student, takes a below average student, and it makes them better. In every circumstance, reducing the number of students per instructor resulted in a better educational outcome. And one of the things that some people are looking at right now is, in place of putting a warm body to pair with an individual student, what if you paired up each individual student with a ChatGPT type derivative with prompting that encouraged learning in that subject? And you can, at that point, you could see a future where you still have a teacher with 20, 40, whatever the overcrowded classes are right now, students, but then that student has access to private back and forth instruction using a technology similar to this to be able to explore that subject in intimate detail, right? So that's a version of the future of this that is really, really, really cool. So after boring them with all of these details and philosophical, things about the singularity, I'm like, it's not a fad. We don't know where we're going to be 5 years from now, let alone 10, and that's what the technology we have access to today. NVIDIA is the only game in town. They were working on their own chips for their Go2 supercomputer, but they recently closed a $100 million deal for the best of breed NVIDIA H100 Hopper chips to power their Go2 supercomputer. People are basically just writing blank checks down, like, hey, give me these things, right? And that's what technology is available today. So, so I would highly recommend for anyone who hasn't already, open up a ChatGPT account, and if you would like, especially if you're building robots and have computers or lots or something, go through these steps to download and install this text generation UI, which I'll walk you through the steps to get started, and I'll show you how easy it is to grab models. And then we'll talk about some of the different ways you can flip it with a stick and how you can use this text generation UI to test hypotheses and conditions to see how this technology might be of use to you in a robot project. So in the text generation UI GitHub, I'm going to try to post it again. Copy and paste. That makes sense. So that link doesn't belong to there. Text generation UI. I promise you, I'm good at technology. All right. There's two ways to get this installed. Anyone who's played with Python understands the concept of DLL hell and having exact versions. So if you're going to install this by hand, if you're more familiar with Python, you're going to want to install conda. that Python abstraction environment. You're going to set up a new environment with the version of Python that you want to use. And then, go through the instruction, download the repository, pip install requirements, and then you're good to go. It's pretty straightforward. They also recently started providing access to a one-click installer for Windows, Linux, Mac, WSL. When you download the zip file, you get a handful of files, including instructions. And the way this whole thing works is you open up a command prompt, you unarchive the zip file, and then you just run command windows.bat. And it automatically downloads and installs miniconda, that virtualization environment, downloads and installs all the support files, the Python stuff. The whole thing can take between 10 and 30 minutes, depending on how fat your internet pipes are and the speed of your laptop. But then at the end of this, you can then run this batch file a second time. And it brings up a local web server to be able to do all the fun stuff. So aside from running this in the command prompt, so far I'm going to stick by my guns and say this is zero code. So once you have it installed and running it, it'll publish a link that you can copy and paste into a browser. And you have access to the user interface for textgenerationui. This is a complete Swiss Army knife. They're publishing updates and changes every day. And yeah, that's interesting, Carl, that you mentioned that about Khan Academy in the 2000s. The Khan guy, I think, is the one that gave the TED talk that suggested this is a possible future avenue for instruction as well. I think it might have been the same guy. Good point. We're going to put these two pieces together, and then we're going to start using these large language models. Now, I had mentioned HuggingFace before, the go-to repository for these downloadable files for the links for the large language models. Another key player in this is a guy called the Bloke, Tom Jobbins. What this guy has been doing is he's been taking the full weight models that are available. So we're talking about 2 bytes to 4 bytes per parameter. And he's been applying a couple of recent techniques to make the model sizes smaller. And he's been publishing those smaller files, those smaller models. So one of my favorite ones to use, 7 billion parameter version of the Llama 2 chat model. So that's 7 billion parameters. And if each parameter is 32 bits, which was up to recently how we worked, 32-bit floating point number, 7 times 4, 14. So that's 28 gigabytes of language model, or 8, 13, yeah, I think I did that right. With the GPT J6B that we did 2 years ago, like the revelation was we could downgrade that to a 16-bit floating point number. And we were pretty sure we were getting the same results, but there was actually some contention in academic circles that reducing the resolution of your parameter of your down from 32 to 16 would result in a degradation of performance, meaning it wasn't you were getting the same results. That's actually been proven to be not accurate, so it wasn't a big deal. Since then, we figured out how to whittle the parameters down to 8 bytes using some more magic, which means that the 7 billion parameter model could be run on a graphics card with 7 gigabytes or a little bit more. And then even more recently was this technique called GPTQ, which could quantize the model down to 4 bits of parameter. I don't understand how that works. But the fact that it exists means that this model right here available on the bloke, our HuggingFace hero, is it's actually 60%, but I'll round down to 50%, 3.5 gigabytes. So on most modern graphics cards, also making it faster to run if you don't have a graphics card and just are running it on your CPU just for lulz. So here's the two pieces that you're going to play with. You'll find the model that you want to download, and there's literally thousands of them on HuggingFace, but I would definitely recommend starting with this one. Go ahead and hit copy next to the model you want to download. And then you go back over to your text generation UI on the model tab. And then you hit paste, and then you hit download. And it's as simple as that. The larger models take longer to download. The smaller ones take less time. And it automatically, well, when you hit download, it downloads it and puts it in the text generation repository, and then it's available for use. So I've been grabbing all kinds of them. I've also already been working with that one right there. So once it's downloaded, you can select it and then click on load. And it loads extremely quickly because it's such a small model. All right, so the model's loaded. The next one that, as you're poking around, I'd highly recommend you take a look. Truly a Swiss Army knife of a program. Under the parameters tab, you have access to some stuff. I wouldn't mess with any of these knobs for right now. There's a bunch of different presets that should make it a little bit easier to work with one model or another. Previously, it would default to Llama Precise. It looks like now it's defaulting to Simple 1, and that's fine. This model, these Llama 2 models have a maximum token size of 4,096 tokens, which is a lot. The only thing that I change on this page is I'm like, you know what? Max response, let's set it up to somewhere around $1,000. 1,000, just in case asking it for something cool. So let's go back over to chat and let's interact with the model. There are a couple things that it says. It knows how to read the end of a response. This is all built into the program. So good morning. There's
That's ridiculous.
How may I assist you today? In the background, on a pretty beefy graphics card, it can hit up to 20 tokens a second in response, so it's pretty good. And what's simply amazing between all the technologies that come into place, from the quantized 4-bit model, Llama 2 being trained on 1.4 billion tokens, and then fine-tuned using reinforcement learning on chat transcripts, so it automatically has the gist of chat anyways, or instruct or anything else. What's the top dewormer for cats right now? And what's simply amazing is that what you're looking at is the encapsulation, the summarization, the zipping up of the gist of the world's knowledge available on the internet in 3.5 billion bytes. Can you respond in, right, and we did a lot of this before. Okay, well, I didn't really follow along on that one. Right, so, and what's happening in the background is it's basically formatting in, and it's supposed to be passing back the previous response back as input. This is your context. So the longer that you talk, the more back and forth that it has, and you can do things like the classic, are the top 5 hard sci-fi. Right, and Let's just make this full screen for a minute. Yeah.
I wanted to point out that our concept of how much information, how much storage it takes for information is a little bit, it's not very good that humans don't have that great of a capability. Because, but we do have examples. Like, for instance, in 1995, Encyclopedia Britannica came in a 2-volume CD-ROM. That's only 650 megabytes per.
Yeah.
So, 2 of those was the whole encyclopedia, and that A to Z. So it's kind of like, things store pretty well in human written language. Anyway, like all the written language and that's a huge amount of information. You could consider encyclopedia like covering a lot of ground, and that was fitting in way less than this. So this thing is, and it wasn't compressed. That was completely uncompressed. So you can imagine how much information could fit. As like some people, like Chris Albertson will say on our news groups and wherever, that the ChatGPT or the large language models are finding the best way to compress information, sort of through the training. And it's like by definition of how it works, sort of. And so you're getting like a Uber encyclopedia. Sort of.
Yeah, exactly. To like grab a quote from from the movie Contact. Incredible movie. Watch it once a year.
Oh yeah. Oh really?
Yeah.
I like that.
Not only does the 3.5 billion parameter model contain the some knowledge of humanity available on the internet, but also the means to access it. Sorry, if you're not a Contact fan, it doesn't make any sense. Anyway.
Right. I have to watch it again now.
Small moves, Ellie. Small moves. So to just get a feel for the models, and if you just want to chat with it, this gives you roughly the same experience as ChatGPT, but now you're running it locally. And there's a lot of us that are kind of chatting as well as the experts, trying to figure out how does this relate to the more general artificial general intelligence application to robots, coordination, right? Trying to figure out how to tweak the prompts in such a way that the large language model can respond in a command that your robot can use. I've got a couple of thoughts on this. Again, this is a no-code presentation, and we can use the features of textgenerationui to kind of explore that. Now, the chat interface is a simple back and forth. It'll capture the memory from the previous ones, and it takes it as input, and more or less you can continue conversations. Because of the reinforcement learning, they tend to hallucinate less. But they do still hallucinate. Every once in a while when I run this, it'll, if I do like a top 100, it'll throw something in there that's not actually a movie, but it'll have like the year and the stars and stuff in it. So they're not all the way there yet. But through clever manipulation of the prompt and the context, you can minimize that. So there's a couple things I want to show you. Again, all things that you can do on using this interface. So I'm going to switch over to the notebook view. So we're going to strip away all of the chat capabilities, and we're just going to put in raw text and see how it works. Now, one of the first things you might be wondering is, because I know I do, is there was something on here last week where you could tell it how many tokens were in the. Okay, all right, maybe that's just the number down here. How many tokens is 4,096 tokens? Like, how much room do we have to work with? How much of the conversation will it remember? or how much information can be stuffed into that context to get what we want out of it. So just to get a feel for that, I'm gonna go ahead and grab some text from a chapter of a quick read called The Metamorphosis of Prime Intellect, an online short novel that explores what happens to society when you get the tipping point between AGI and superhuman. There are some adult themes, so I wouldn't recommend this for our younger viewers, but I've probably read it 3 times over the past 10 or 15 years, and it's pretty good. I'm gonna go ahead and grab some text from chapter 2.
We should publish that link.
Yeah. And let's just grab some text and paste it in, just to give us an idea of scale, like what. All right, so we're not even at, we're pretty close to within a couple hundred characters. So when you're crafting an input context or a prompt, here is, in a Llama 2 model, how much room you have to work with. So you have a lot of room to work with. Which is
4,000 tokens?
4,000, yeah, 4,096, yeah. And a token is about 2/3 of a word. So you can count words and then divide by, or multiply by 0.75. But it's kind of fun just to paste it into the thing and see. So this would be about the limit of what, but this is a lot of room to work with. And so in one of the things that I would encourage you to think about when you're thinking about ways to apply this, a lot of us are talking about we're talking about the large language model as being the brain, right? And we're like, okay, well, let's try to get the large language model to spit something out that we can use in our robot. So we're doing clever prompting. We're trying to say, hey, respond in JSON, do all things. But in kind of like a naive approach to how large language models and robots, we're like, this is the end all be all. So, and then we get disappointed because the large language model itself is an encapsulation of a snapshot in time of the information available during training. Fine-tuning these up until very recently has been very cost prohibitive, so it's not like you could stuff more information to it after training economically. And so that's where a lot of us are stuck is, okay, well, this is super awesome. We don't know its limits, but we're kind of lost on how we want to use this with a robot. So one of the things that I've been toying around with is, instead of looking at it, the LLM as being the end all be all, let's start with looking at it in a more traditional sense, Python code. Let's look at us being in control of the robot's intent and what it does and what it's capable of. But this Python code will then feed into the large language model as part of a humanizer or a humanifier. We'll set up using Python the context and the prompt to elicit the desired result, and we'll use the LLM for the conversational aspect of it, right? So we'll set it up, and we'll set it up for success in a way that the output from the LLM, you know what it wants out of it. It spits something out, and then from there, you go in, you do something, and then you fit it back into the Python. So when you hear about LLMs being used in industry or exploration, they're not trusting an LLM to give someone increasing their medical records because it tends to hallucinate. But one of their approaches is the Python code. When someone calls in, we know who they are, we verify with their, their medical records number and the last four of their social, right? We've done this when we've called in. And then based on what they're asking for, we can pre-populate that information using Python code into the context. And their LLM is fine-tuned for the gist of the output that they want, right? So the LLM isn't tuned that Alan has high blood pressure, because that would be onerous, but their LLM is tuned so that when their input context includes information about my medications and information about my patient record, and the input from a previous prompt was, hey, when can I refill my blood pressure medication? The LLM is fine-tuned on the gist of how to respond to that. So for industry applications, that's one of the directions they're doing. And I keep trying to sweet talk Brian into giving a talk on his work with line chain and stuff, but it's a similar thing, right? The smarts go into here, the LLM becomes a humanifier to soften the interface and make it more human to get stuff done. So let's look at this for a little bit. We've got a couple minutes. Let's switch back and share my screen again. And so we've got this raw text box. And in a typical conversational fashion, oh gosh, what is it? It's a user assistant. Okay, that's some extra stuff in here. Right, and so for right now, this looks like, this is exactly what's being fed back in behind the scenes for a chat interface. Now, if you go and ask it something like, what time is it? It shouldn't be able to answer because it has no access to any of that, or it just hallucinates, even more better, right? So a little bit less useful. Now, we have total control over what we refer to it as a prompt. I'm going to call it a context because it's more than just prompting it for a response. So let's start adding in some information here. What if, as part of our Python, when we're writing this code, before every prompt, we insert Saturday, September 9th, 2023. Cheers. 52 and EST. Right. So what if, when we're constructing the response to feed into it, before we do the current language model, we just stick this in as part of the system context. So every time we go and we bounce this off of the LLM, we update the current date and the time. Right? And that's part of the Python that we control. Now we've set up the large language model for success. We've provided information about it automatically through Python. And we have a little bit of extra stuff in there that's just being chatty, right? And now, because we've given it that information, there's a much, much higher probability that it'll generate a meaningful response, contextual response, based on the current date and time.
Yeah.
And even so,
try removing the word Saturday and see if it
probably
figure it out.
You want to see? Okay, yeah. Actually,
It
let's
should be
try
able to
that.
do that, right? Oh, well, that requires a
It
little lot of
depends,
logic.
right?
That's logic.
Like, I wouldn't be able to it. I wouldn't be able to do it, but I don't know about.
Or maybe it'll just say September 9th. Yeah.
Okay, so
What's the day of the week? You can force it to answer something or try.
Yeah, that's, it's probably not going to be able to handle the data.
Right, so in its knowledge, we're using the small model, based on its information that it has about calendars and calendaring, it just wasn't able to figure it out, so that.
Would it know another time zones?
Huh?
Would it know another time zone instead of specific standard time?
Yeah, well, let's ask
Well,
it.
you'd have to say what day of the week is it to be sure you're getting the right question. Yeah,
Yeah, let's ask it.
that it should know.
11, 12.2. So if you're able to give it enough information to figure it out, you can actually go a couple of different directions, right? And this is simple date and time. When I get back into coding, I would probably choose to add in the current date and time, update it with every input just in case, right? But it gets even cooler than that. There's a whole set of tools out there, an ecosystem called LangChain that allows you to do all kinds of interesting things, including accessing the internet, accessing calendars, vectorizing input, again, to use as input to the context for your interaction to get what you want from it. So just continuing down the line, and I haven't tried some of these out before. So let's say I tell it a little bit about my mom. Birthday is June 16th, right? So imagine a way of this where you start some type of a database of interesting things, right? Or access to your calendar. So when you go in and you ask the question, when is my mom's birthday this year? Let's make it October. Obviously, this isn't. Don't tell her I don't remember her actual birthday. She'd be so upset, right? So in a possible workflow where you're crafting the context to be useful, your input is, when is my mom's birthday this year, right? So that is something that you evaluate in code. I'm like, oh, this is mom stuff. So just picture a database of things, including mom and her birthday. Your code then populates facts that we know about your mom into the context. And then we run that whole thing through the LLM washer to see. Now, as an added bonus, it has to be able to relate two different concepts. I actually haven't tried this yet, so I'm excited to see what it's able to do. Brian, what do you think? Think it'll be able to figure it out? It's got to piece 2 and 2 together. Wow.
What about next year?
Actually, let's try it. Yeah. Right. So this is where I start to get excited again. Using the large language model as the end-all be-all right now with the current limitations is kind of a non-starter. But when you're looking for application in robots, if you look at it differently, the LLM not as the output, but as the humanizing filter that makes interacting with your robot human-like, you can then take the ball, stuff as much as you need to into the context, and it's able to be useful then. Now, you're not going to get from here to having your large language model wander about on its own. That's still being handled in your Python code. But for interactions, tying this up with a voice synthesis module and a automatic speech recognition like Jim has and I've toyed with, this brings it back into our ballpark, right? This is just Python code, leveraging available tools, a database, and some smarts to take it from a novel curiosity of plausible conversations to actually useful, helpful stuff.
So do you know how many days you do lunch with it?
Yeah, that should really. Yeah, maybe. Yeah, that's logic. But it's
maybe, he's bad at math usually.
No.
I don't know if that's right or not. Okay, let's check really quick. All right,
Should be,
so
'cause
7, 14, 21, 28, 32,
30 would be October.
40.
Yeah, that's right.
What?
Because 30 would be, 30 days in September, so 30
Okay,
30
so-
would be October 9th plus, October 10 plus 10 is 14.
I just want to, there's no.
Oh, wait, 14.
Okay, so it wasn't quite,
It's a little off.
a little off, okay.
No, it is correct, actually. Yeah, because that's 22 plus the 2, because you started on
Like
Monday.
9,
So it is.
30
Okay,
days
so
of September.
7, 14, 21,
It should be 21 plus
28, 28,
16. 21 and 16, that's
31,
21 and 16 is not 30,
32,
37 days. 21 is,
It's 37 days, guys. I just checked.
yeah, it's
31.
37, that's what I said, 37.
Okay, so that wasn't quite right. That might be a bridge too far for the 7 billion parameter.
It's not doing, again, there's no logic in there, so it can't, it doesn't do computations well unless you set up like an example. Like actually to continue this, you could say up here, there are, 30 days between September, you could give us a few examples.
But so,
Go ahead, Brian.
what we do is we tell it, you are bad at math. Always use a calculator, and then we give it a calculator.
All right, so.
Oh, give it a
That's
real
yeah.
calculator.
So-
You're probably
Yeah, yeah.
into this.
So here's what I want to wrap up this talk is
You can go over to.
we're actually, this is a good point, is a stopping point, is that you can get started on testing the limits of this technology without writing any code at all by just using this tool and knowing how to paste the HuggingFace link into the model. The magic to get these to be useful from a robot context is to take ownership of the context and the prompt and use the large language model to humanize the output. So you put in your Python code determines how to split the stuff in the context from your input, and then that whole package is sent to the large language model to humanize the output. There are limitations based on the abilities of the large language model. Generally speaking, the larger the large language model, the deeper its capabilities. So what I'd like to do is to take this exact situation and let's bounce it off of ChatGPT. That was the wrong button. New chat, new chat, there we go. And to see what it does with it, because I've been surprised. There have been things that, based on my guess about the model size, can do that my 70 billion parameter local model can't, and I'm just curious to see. Was that the right number, 38?
Actually, depends on, if,
37.
well, it depends on, that's
You
like a
include
wow.
today.
Depends if you include today or not, from midnight to.
22 and 16, so it thinks that there's,
What is this?
I'm a little embarrassed.
There's 21 days left, right?
Yeah.
But if you include today, then it's 22.
And so finally, let's bounce this off of the 70 billion parameter model, just to see if we get something that's more.
What was that one you just did? That was this,
13?
that was 13?
That was a 7.
What was the first, the one you, I thought.
Oh, the one that I was running, that's the 7 billion parameter model.
Then you upped it to,
Yeah, so then we tried ChatGPT, now I'm gonna
Oh.
do the 71. Just have to do a little magic so that it knows how to fit on the cards.
What kind of monster are you running this on?
this is just his, isn't this your 3090? Or
Uh,
the 3090?
no.
There's a couple of them, yeah.
Yeah,
Yeah, but
it
this,
wouldn't fit.
why, which model? Which model,
He
what,
said 70 billion.
70? Oh, I thought you said,
Yeah, so this is the 71, just to see.
I'm sorry, I thought it was, yeah, it was 7 first, then 17.
Oh.
Worse than
Damn.
Oh, wait.
You know what though? Hold
Did we
on.
tell what year it is?
Yeah, I get it. Let's do the other one. There's a different platypus that
Well,
that isn't
if-
instruct.
If there's a leap year, that would affect February, but not.
Yeah. We have this one more shot and then we'll wrap up the top.
It was told the year and it said, I need to know the year.
Mhm.
So
Yeah.
it's kind of like,
Okay, so this is the instruct one. We'll go back to notebook. Yeah, that was wrong either. Okay, so bad at math. Maybe ChatGPT is right, but I'm not smart enough to figure it out. So, you know, post to the forum. Let us know if you're trying it out. But like, this is the magic by creatively arranging the information in the context and then using the LLM as a humanizing filter to be able to converse with, you know, data, PDFs, or all right. That's it, only 5 minutes over, thanks.
Yay.
I'm sorry, Alan, if I took too
No,
much
no, we're
time.
good. No,
You
that was
had
perfect.
All right, so let's break for lunch. You guys want to come back at 1 o'clock?
All right, let me, I'll call the outpost, because we looked up the phone number. See if they're open.
Yeah,
We
school's
just
in
like
session,
rolled
right?
it.
You guys started back last month, right?
Yeah.
So they usually would be,
So yes, the semester's back on, so
but we don't have to go to the outpost. Their food choices are limited. It's what?
It's better than 7-Eleven, I think.
Oh, well, yeah, but we generally either, you know, there's a Chinese place, and pizza, and.
Voicemail?
busy.
Should I go up to the corner?
Okay, yeah, we can still do that.
Oh, are they not there?
They're not picking up, and you're right, the food's better on the corner anyways.
Yeah, I was thinking, like, I always try to go to the outpost if I can. I'm like, why? Well, it's because it's the closest place, right?
Yeah.
Technically,
nothing to do.
unless you go there and then it's closed and then go somewhere else.
No, got it, right.
All right. Is,
Sure. I guess it's sunglasses.
So, you guys stay, hey, better
Yeah.
stay here?
Okay, sweet.
do you want us to grab anything for you?
Sunglasses.
Let's, pause the recording.
All right, so that's the end of the business meeting. We are back.
Hey, Ben,
Yes, Thomas.
I forgot to add some last thing to tack on to the business meeting. I was made aware of the fact that Google will give you approximately $10,000 in free advertising if you are a nonprofit. I don't know if the club would like to take advantage of that.
Sure, we need to look into it.
Yeah.
I've never,
Let's talk offline if you guys are into it. I can tell you what I found out.
yeah, if you can give us a link or something, either on our forum or somehow an email.
Sure.
Yep.
$10,000, that's a lot of advertising, and you can have it very, very specific people in specific places.
Yeah, if you can give us the info on the forum or send us an email.
All right, will do.
Thanks, Thomas.
Sure.
Right, so let's start the show and tell, which I think Jim, you were first. Yeah, you were first, Jim.
I don't know. I was just trying to do this.
Would you like us to come back to you?
That's who wants to go? Are you going
Well,
to
you
go?
know, if you're ready, let's do it. If you need a little bit more time. we can-
I was just trying to get that phone thing. I'm trying to multitask. I'll do that later. Yeah, so a couple updates actually. The first one, I kind of was, or in the past month or two, I've been, I proposed a new contest, right? And
Oh, yeah.
so this is with it's sort of combining vintage computing with robots, doing this RobotWar contest. So here's oh, I need to. Hold on a sec. I should share with audio and stuff.
I started my virtual robot.
Oh, you did?
Yeah.
Oh, good for you. Yeah. So I'll share screen, sound, video. So here. So this is what it looks like. The this old software on the Apple II Plus, and from 1981. So then I go into it and again, here, example. Annihilate. And this one's called Meeting Plus had a 1-bit audio. You just
But the sound effects are the best part.
I turned it down to, that's 1 tick above silent from the movie player. So yeah, you can see it's kind of interesting to watch. And then, even though like each of these codes of these is not that sophisticated, but then when you put them all together, you get something kind of unpredictable. You don't know who's going to win.
Is it a tag thing? What's the?
So it's anyway. I just wanted to show you that part. Then I'll show you.
It first starts off with a 100%.
It's a kill or be killed, basically.
And each one is shooting at the other. When they scan, find something to shoot at it, and maybe move or whatever.
And also bump. Yeah, it's health.
Yeah, when you get hit, then you want to move out of it. Scan and shoot, and once your health goes to 0, you die.
So was that all the people on the mailing list that submitted their code?
No.
No, we haven't done
Nobody's
that.
done it yet.
Oh, no
So
one's done
this
it
is
yet.
an example.
Oh, okay.
This
I've never
is,
seen that
I'm sorry,
thread.
this is an example. The
Okay.
only, Ralph is some guy, but, that hacked the program or something. But let me show you now, the next, I want to be fairly quick because I got another thing, and I got another show and tell after this, but.
To the left-hand side.
So this is,
and
what.
then you see it's in,
like.
that's disk drive number 1. Now do Control S.
So, well, here, I have a video here that walks you through how to launch the Apple II emulator here that you can download for free, and then I provide the disk you need to launch the game. It's what is this? I don't even need to show
Is
you
that
this whole
video on your YouTube?
This is on YouTube. Yeah, I sent this out. So it boots it up, and then you go to this screen again, and then now I'll show you. I'll show it from here.
At the main menu. So what we're going to do is we're going to edit a robot source code, number 3. So just type 3, and now we're in this editor,
I'll show you.
Existing robot from what's in here. This would be a good place to here.
And it's fairly simple, and there's also a manual for it, which I have. Can show you as well. It's
just a manual online, but.
Yeah, I sent it out as well.
Yeah.
And it's also in my web page right here, or over my, up to my Google. Oh, I went to full screen. So here it is, the manual, and you can go down to the writing and editing source code.
Mm-hmm.
This is for all ages. This is not, you don't have to be a programmer or a very experienced in any coding to understand how to do this. It was made for gamers back in the day. Maybe gamers were a little more sophisticated in 1981 than they are today. All you need today is a joystick. No, but there's some games today that are very complex. But yeah, the code is simple. You can detect damage. You can change your speed. You can do this radar thing, and if the radar is negative, it means there's a guy there, and then you can fire at him. Anyway, it's all outlined. So I haven't done my own yet, and then yeah, this video shows you how to save it out to another disk, and that's how I would collect them. So then yeah, you would save it out to a disk image. It's just a small file, 143K file. And then you'd send the file to me, to us, and then we could put them all in one machine and then have a contest. So it's kind of cool to go down this retro path and see the kinds of things you can do. And it's on a slow old machine. You can even run it on the real hardware. I have it. So that's the. Any questions about that? That's the contest.
I think it's really cool, and I started playing with it. And some things you'll find this text editor.
Oh, it's
You
terrible.
need a lot of patience. You need to look at the manual. How do you go up a line? And
Yeah,
it's really, it's great. It's fun. It's like the old days, right? The old days.
You can't even use your cursor key.
But it's still fun, And the second fun thing
Cursor
is I think it's like you're taking turns on instructions. Like you get to run one instruction, the next robot runs one instruction. So you need to really think about efficient code and think you can't make a giant block or else nothing would happen, I think.
Yeah, it's very, very slow processing, and it was criticized for that, even though it was highly liked in its day. This program, like that quote I posted, some guy said, "Oh, I love that game. You got to write your own little code and run your own robot autonomously." Like someone was saying autonomous in 1981, But yeah, it's a little bit of a voyage down some sort of vintage frustration to using the editor and stuff. But
Carl says it would be nice if there was a JavaScript version.
well, I mean, there is an option. There's a newer version of this that I also posted about on a PC thing, and it's in color. And I don't know if I have it on this computer, but it's a little better, and you can use regular text editor. But it's not quite as vintage, and it's there's been 1 million people using it, or in the old in the 2000s, early 2000s or something. That you had contests all over, and there's a lot of code already out there. So you wouldn't be as creative. Someone could just pick one of the winners of these contests and submit that, I guess. But yeah, there's a slightly newer thing, and it's almost the same. It's the same concept, and it's a nice old PC app. So if you want that, we could go that route. I don't really.
I like this one.
There was one that I played along. I think I looked at it was 1985 instead of 81.
Oh,
it's C robots, and you write it in the C language, so you can get it's a little more expressive, and they can do fancier things. But this is still cool, more retro.
Yeah, the thing is about this is it's a very simple set of commands, and so anybody in this room could handle these things. It's not complicated. It's like, you know, am I damaged, and is there another robot in my scan, and at this, and then fire, and you know, that kind of thing. It's really, I love this retro artwork. So that's. Yeah, so think about that, and yeah, who wants to participate, play around with it. I'll repost if you want, and then people can play with it on their own. And John Davis is interested. He thought it would be good. He thought it was a good idea.
Would you like to schedule the competition like next month or something?
Or do we have enough? Well, first of all, who would participate? You, Brian, you would, I would. And John Davis would, I think, unless he bailed out.
I mean, at least we have for one, what is it, 5 at a time?
Yeah, you need 5. So we have 1, 2, 3, 4. We got 4 people.
Yeah.
And then we could throw in an AI bot, or one of the
Cooper.
Yeah.
Cooper.
Yeah. Let me see if I can get GPT. Oh yeah, have the Apple II communicate with GPT and ask what to do next. That would be a stretch. All right. Okay. So, all right. Well, yeah. We want to schedule for. Usually, we like to do 2 months or something, right? I don't know about next month.
So
Yeah, next month is a bit tight because of the.
November?
Yeah. I mean, I'm up for.
Sure.
That's because people can troubleshoot in the next meeting. Hey, I couldn't save to a disk. And we can
Yeah. We had, nobody's agreed to do the contest yet, so this would be the first, and then we need a month.
Okay.
So let's just set it for November then. And,
Tentatively.
well, yeah, we'll confirm.
Next month we'll confirm.
But and if we get more people, good, you know,
Yeah.
but I'll try to get the word out again. But yeah, it should be fun, because the whole bout is only 3-4 minutes, you know, so that there's only one.
Well, we can do best, you know.
And then we could run it 3 times.
That's 2 out of 3, or.
Yeah.
I think they have like a tournament option where it'll run a few times to get best out of 5 or something like that.
Oh, okay, I didn't even see that. I don't know if this.
I didn't try it because I never
I don't know if this
went
one-
through it.
Yeah, it does.
You can manually do it, just run it 3 times.
Just run it 3
Yeah.
times. I don't think this
But I
one
think they'll
had.
actually do that for you, list the robots and it'll.
It may have had that. Well, yeah, you can see here. Well, in the main menu, schedule an automatic match.
Yeah.
Yeah, I think that runs every few minutes or something, but you just have to watch it. But like this one doesn't actually have an official tournament.
I think that's it, the match.
Just
So
run
you
a-
schedule, I think you set the robots up, and then when you run it, it's actually running the simulation.
Yeah, because I start a robot battle #1, that runs 1.
Yes.
You
And
have
then-
lots of time to figure out exactly what.
Yeah,
right?
but
Yeah, we can do that.
I think this whole thing is set up for exactly what we're doing.
Yeah, I think it is, yes. I'll look into that. I haven't really got to the match phase yet, but I guess I should have looked at. So the other thing I did was, I guess, it's Cooper, time to bring up Cooper for a second, because, where's my, so I tried to summarize last month's meeting. So the text was 150K or something. And, you know, with Ross's talk, unfortunately, it didn't seem to come out, maybe because he was online, but the first time I ran this through, GPT said, I can't help you with that. For the first, I break up this 150K thing into chunks that will fit into the 16K GPT engine. And it said, I can't help you with that for the first quarter of the whole talk, and then of the whole session. But then I broke it up and sent it just alone, and it gave me a response, and it was talking about my stuff, like the prompt engineering, and then prompt engineering with a Ross something or other, and so it's like, lost his whole talk condensed into a few words or so. It just like it couldn't understand, and all I can think of is when I read through some of this, it's just like it didn't like get full sentences or something. So, but it did get the rest of the talk. So all this stuff, all this.
So that was it, listening?
Yeah, this was all the listening, and then I just yesterday I sent it through to get summarized, and so now it's got the summary. Oh wait, I was supposed to. The one thing I had to add to, I added like this is this transcript of the August meeting. Okay, I just want to give it a little heads up, but it's interesting because the people that were here were telling me they were talking about a bunch of stuff, and this is talking about like people in Florida, people who live in Florida are talking about their allergies and suffering and stuff. It's like here, their family moving to Florida, air quality due to planting of different types of trees. This happened during lunch.
No,
So-
Wow.
So I want to see what let's see what Cooper says about, assuming I got this correct. This is just 2 lines with the full summary there.
Yeah, last month, during lunch, we started talking about the fires in Hawaii and all kinds of stuff. And so he was listening to all of
That's funny.
that.
I don't draw these anymore.
Hi again. I'm ready to resume our conversation from where we left off last time.
Give me a summary of the August meeting transcript. Didn't get that. Oh, good news. Oh, okay, you guys don't.
Okay, so that we can see this now.
Yeah. He said something, but
A lot of red text.
he's getting an error from the text to speech. So I don't know how come I can't get out of what is full screen, alt F11? Oh, just F11. Let's see, and then, yeah. Well, if my token is, I should have checked this earlier. Well, the token should all be good. Let me get into the,
Hi again. I'm ready to resume our conversation from where we left off last time.
if I have to log out, this will be better. Or I can actually just do it via text in it. Let's just do, well, I guess that, let's just do a text interaction with Cooper this time because his regular full self isn't seem to be ready. So I have the, should have one of these, Cooper, there it is, Cooper OpenAI. I haven't touched this stuff in a while, but if you write good code, it should work the next time. Okay, is this the text? This looks like, let's say August. Yeah. Say that Florida part. Who knows if it's got the there it is. This is August meeting. Okay. So let's see what this is. I can make it big. Okay, during the August meeting, various topics were discussed, including prompt engineering for language models like GPT, the application of AI and automated tasks, the use of GPT through the question answering, troubleshooting techniques, and the importance of context and consistency in AI conversations. The meeting also touched on topics outside of robotics, such as allergies, mental health, and partnerships with educational institutions. Members showcase their robot creations, discuss collaborations with companies, and share their experience with GT models. What points were made on prompt? During the meeting, prompt engineering highlighted as a crucial aspect of effectively utilizing large language models. The speaker emphasized the importance of providing clear and specific instructions or prompts to guide the language model's responses. They discussed how prompt engineering is used in their virtual human project, Cooper. There is to shape his personality interactions. The goal is to create prompts that accurately describe who Cooper is and how he should engage in conversation. Prompt engineering was also mentioned in the context of other applications such as summarization or recorded meeting transcripts can be used. Well, that's in fact what we're doing.
That's exactly what we're doing.
Geez, this thing is eerie. Anyway, so that's, I didn't modify the transcript at all, other than to put the word August there and to just like cut out the portion where it got confused. But essentially, I had to. So on my code, I won't bring up any more code. That seems like I've got my quota in. But the code looks at, takes this huge bit of text, breaks it up into pieces that can fit. Like it's 12K, essentially 12,000 tokens input is my limit, assuming that you want to leave 4,000 for output. It never uses 4,000. It only seems to do several hundred or up to 900. But I'm using a 16K model, which is a little more expensive, which is double the price, which is still only 2 cents every time I run it or something. And so I automatically, this code I wrote, break up any size file you have, but it breaks it into equal size chunks. It does a token check on it, and then counts the tokens. That I have a token counter routine that I got from OpenAI anyway. So it's and it breaks it up and then sends each of those chunks and gets a response. But again, I mentioned this last month, is that when you do that, you're breaking across boundaries of possibly one speech into the other speech, or lunch, or show and tell. And so you'll get some duplicate kind of things going on because the summarizations of each of those chunks has some overlap.
So how do you stitch it together? Like before you send it, do you tell it, I'm gonna give you a whole bunch of pieces, or like one piece and then here's the next piece, and here's the next piece, here's the next one?
Yeah, I do it. Yeah, maybe you could tell me how to improve this code, because I haven't put any time in lately. But all I do is I literally divide it and send each chunk and say, summarize this in 1,500 words. Okay, and then the next chunk and the next chunk and the next chunk, so they're all disjointed. And then all those summaries just get appended to Cooper's to Cooper's chat log. Yeah. And so when you run Cooper, I've been appending them to the file as though that was part of the previous conversation. So in other words, it's pasted in, and so now he has all of that summary data. And then you ask new things, it's using the summary above. It's all in one line, like you saw that here. And this whole thing is all one line of this is Cooper's system description of who he is, and then all of this is the summary of the August meeting, this whole chunk, which was done in 3. I threw out the first one because it totally messed up Ross's talk. It didn't have anything to say. And I'm not 100% sure, but I told it, I commented out the other 3 chunks and just sent it the first chunk again alone. And it summarized it as talking about prompt engineering and a little bit of Ross and a Raspberry Pi. It basically got like a some very minor points from his talk. And so I think it must be the, I didn't really look through this transcript very well, but I don't think it got very good sentences out of it. Like if you look at some of this, you know, it's not very clear what's happening. You know, it also, yeah, so you kind of have to be, I think, you have to get this language model to work well, you need to have a very sort of thought out speech, like I'm doing right now, very thought out and not a lot of ums like that. You know, it has to be kind of scripted almost, and then it comes out, then it can get a hold of it. Plus, if you have audio problems from, you know, having, you know, my transcriber may not have picked it up as well from the audio in the room. But, so that's that, and I scared off one group, but yeah, I think it's still pretty cool to do this. This is the code, if you want to see. I'm a coder, so I always promote code, because code is salvation from computers. So, you know, it's the only way you can talk to them, really, at the low level. But this essentially is called chatbot memory class, and the main thing it does is, I commented this part out, but again, the main code it does is it creates this class, loads the file, loads the summary, and then make the summaries, and then appends to the file. So yeah, appends to the file. The make summaries obviously is the big chunk of code. That's this. So it's basically making adding a user message and sending it to OpenAI, and getting a response from OpenAI, ChatGPT 3.5 Turbo 16K. But yeah, that's just, and the most interesting code is breaking up into chunks, where I create a fraction, and then I do this calculation, like Alan was talking about, words per chunk equals 0.75 times tokens per chunk. The token I have in OpenAI, I have num tokens from string functions, which is really convenient. And anyway, so then one thing I had to kind of figure out was how many words, how many letters is in a word on average, and
Yeah, I'm actually like multitasking.
so 5 is like the industry standard, because that's how I divide the file, because I need to know how many characters. I was trying to write some code to go to the middle token of this file or something, or I haven't done that yet, or I started to do it, didn't finish. So but that's the summarization stuff, and it can be quite useful, I think. Anybody want to ask anything else, or I'll finish up with that.
Any questions online?
Stop me.
Carl said, can we get Cooper some help? Seems like he's been hitting the silicon pretty. A bit too much.
Silicon, yeah, silicon alcohol, let's call it.
He's been hitting the silicon a bit too much.
Silicon. Is there, well, you know, remember in Star Trek originally they had silicon life forms, which were made of rock.
Oh yeah, I remember that episode.
Yeah,
the original series.
Of big bags of mostly water.
Oh, is that what it says? Yeah. And of course, Jim, he's of course, Dr. McCoy. Jim, I'm a doctor, not a bricklayer. That was the famous bricklayer, because he actually literally uses cement on the life form
to heal that one,
and it heals.
The one they hurt.
Was that the silicon one? I can't remember if I'm mixing. It was this thing that dug through. It was made of rock. Yeah.
Because humans were mining something from there, and they were like mining the creatures.
It's babies.
It's babies.
It would be silicon eggs.
Yeah.
They were killing. They were wondering, why is this thing killing humans? Because it was defending its eggs or something. Anyway, but my point was, since there's an equivalent, like, you know, the reason behind that whole thing, Gene Roddenberry is a genius, right? He was, if the molecule of silicon can be replaced, you can replace carbon and then put all sorts of hydrogens around it and make a life form out, and that's the theory, is to use silicon in the same place where carbon would be in our.
In the periodic table, though, it's just one below, so I have the same.
Hey guys,
Right?
Ring thing.
Something. I know.
talking about silicon life forms is interesting, but I have a hard stop at 2:30. Can I push ahead?
Yeah, you're ready. I'm done. Thank you.
Okay, so let's.
I'm sorry, Jim. I didn't mean to. I mean, you can keep talking if you want, but I got to leave at 2:30.
Oh, no.
We'll jump you
That's
up.
it.
All right, Thomas.
I don't mean to hog.
Go for it.
Oh, Jim. All right, guys. So I'm going to show off this thing here. I'm going to have to switch over to my phone because I don't have any cameras to point at the. Well, maybe I could do. Let's see if I can point this one at it. That's not a very good viewpoint. Let's see if I get a little closer here without knocking everything off my desk. That's kind of sideways. There goes my phone to the floor. Great. So this is a microbit microcontroller here, and the camera's not pointing in the right direction. There we go. How about over there? Okay, this is a microbit, and this is a Hummingbird interface board. I wouldn't recommend them. They're kind of pricey and they're kind of limited. There's my phone reminding me to get ready.
That's pricey. How pricey is it?
Well,
that's the microbit. Yeah, those are.
Somebody would have to look that up. Now, the project that Trish tasked me to was creating a donation robot where you would take a coin, and she bought this coin device here. Let's see if I can get that better in the camera. And you put the coin in, and then you have to have something happen. So some sort of a animatronic. So I have this little Supergirl Lego. There she is. And she flies around. Right now, I've got it tethered to this Kindle thingy, tablet. And so it needs to be turned on. I'm going to migrate it over so it's independent of this thing later on today. That's the goal today. But for now, I can show you this demonstration. I've had to do some major modifications on the change slot here. It has its own microcontroller with no instructions, and a lot of the boxes in Chinese. I'm not very good at Chinese. I think I know 3 characters in Chinese. So basically, I stripped it down to the basic components and used none of the electronics. But what I did use is it has a LED, place for an LED and light sensor in the back there. And so that breaks the beam, and then that triggers the device. So let's power it on. And let's get my Kindle going here. Let's connect the Kindle. Kindle's off to the side.
Oh, that's your Kindle like reader?
Yes.
Oh, the tablet, yeah.
Okay, it's going because the LED is not in the slot properly, so it's not working now. Okay. It was working at home.
You are at home.
I know. Hold on. I think when I touched it, I knocked something off. It has to be aligned just so, and everything has to be, it can't be too bright or too dim, and onwards and onwards.
Oh,
so we'll try it again. Okay, it's going off randomly now. It wasn't doing that last night. Let me rearrange this a little bit here. It could be a problem with the ambient light here. Ideally, it would all be in a box and there would be no ambient light.
Yeah.
So we'll try that again.
Are you putting in the coin or you haven't done that yet?
Hey, I just got it running 1:30 a.m. this morning.
Ah, that's just like I like to do it.
I'm going to change one of the parameters here and see if this will improve it. Oh, it's not going off by itself now. Now I take a coin here, pennies. I put it in the slot and see if it works. Yay, it worked that time. I just had to make an adjustment in the code for the ambient light, that's all. That's it, that's all I have. It works.
Nifty.
Any questions? No? Good.
So you had to use your own, yeah, you put in your own LED there, not using you didn't use their electronics, you said, right?
I used all their electronics, Jim. This is all that came in the kit. It's a huge kit. It's in the other room. It's a box. It's a box of parts about this big, this wide. It's got sensors and servo motors and the whole 9 yards. It's a good kit, but it's very expensive. And it comes with that interface board I showed you. I also bought a couple of different interface boards that we're going to try out later. Oh, that's in the other box. Anyway, the other interface boards cost about $10 each. So that's a whole improvement on how much was that kit? Trish, can't hear you.
Yeah.
Trish? I don't know. It was a
Sorry, it was a couple $100.
Couple $100.
Sure.
So we're trying to cut the project price of this down to, and how much was the microbit itself, the board, the extra board you bought? Is that about 20, 25?
Oh, the microbit board? Those are $20. I bought a set of 5 or 6.
So with a little luck, we can bring the price of this down to about $20 plus 10 plus a few odds and ends there. So probably under $30 instead of like $300.
Yeah. So this is actually that product was a hummingbird bit, and that is a product that was made by a guy on the East Coast. And it's actually, he got a grant from the National Science Foundation for to distribute this and to support use of this product in schools. So he actually let educators borrow them for free. And because of that, and because of the fact that I helped an educator do some things with Lego that integrate with her curriculum, and she used the hummingbird bit, then I'm kind of adopting it. And then we're taking it beyond that one level to include the simply the microbit and trying to come up. This all goes back to supply chain for makers. We're making the project, but then we want to figure out what is that thing that we do to create the base infrastructure for a donation robot, and then how can we find a consumer that wants to do it? I think it's kind of a fun project. It's not really about money, it's more about having a project, but it could be good. At minimum, I'll get 1 donation robot out of it. That takes, what coins does it take, Thomas?
Pennies and dimes.
That takes pennies and dimes? Isn't that funny?
Yeah,
like,
the device here has a interface that blocks any other coin. You can see it's, whoa, there goes the, you can see there's a slot there that shows you it's just wide enough for one coin. It'll throw everything else to the side.
Isn't that funny? It's hysterical.
It also has devices. It also has electronics that'll stop steal coins, and it's really sophisticated. But we're not using any of that.
Yeah.
We want
So,
a simple
so I'll
project.
just have to tell my donors to bring pennies and dimes.
Pennies and dimes.
I love it. It's a lovely constraint.
All right. That's about it for me.
Okay.
All right, thank you, Thomas. All right, Trish, you were.
Okay, I'm up.
Yeah.
Right. Hi, everybody. You know who I am. I'm Trish. I've got this event that I'm planning on October 7th. I'm going to pull up my flyer because that's all I have right now. But it's based on a number of interactions that I have with educators throughout the past few years. So the educators are educators that are passionate about Rube Goldberg contraptions. The other is Lego, specifically Lego Great Ball contraptions. And then we have some maker displays. I have just a couple of makers that I regularly interact with, you know, friends, right? And so I'm hosting a first time event. Now, those of you who know me know that I created another event a while ago that was that I start things. And this is sort of at the phase where the first National Robotics Week event was when I started it over at the Sea Base. But it's called a STEAM party. And here, I think I finally have the flyer up so I can share my screen. So let me go find the GAM. So, it's this it's this flyer right here. It's lovely and very large here. If I can make it bigger. Yeah. I'm calling it a STEAM party because I want it to be sort of fun as opposed to educational. But of course, we know STEAM is all about the education. And I have Mikhail Thompson is a high school teacher from Rialto High School, and he spearheaded what's called the Rubathon. And actually, that's been adopted by the Rube Goldberg organization as their method for interacting with schools. And so he'll come and share that information. And then we have Robin Conti, who is a physics teacher in LAUSD. And he just happens to be a friend who works with the robotics, the Lego group, volunteers with the Lego group that I host. And then we have Thomas Messerschmidt, right? Who's developing a project that we'll be able to use. And then we have a couple of other people. So so this is the flyer. It's going to be held over at Long Beach City College grounds. So if you've been on the PCC campus, 1305, and I got a little grant from the port so that I could help to pay rent and stuff like that. But I'm trying to organize both being on the quad and then a couple of classrooms. So there'll be some classroom-based stuff. And I also have a master model builder of Lego. He used to work at Legoland, and he's built for Legoland theme parks around the world. So he'll come and he'll do some things. We'll have a free competition. And I have some kids working in a project that's called Teens Teach Tech. and they'll come and we'll give them some thank yous for their work done during the summer. So that's it. So anything to keep the festivities going, the learning festivities, if anyone would like to join us, I would love it. We'll be setting up probably from as early as 9, and I'll have to make a couple of trips from the studio, but yeah, come have fun, join the competition, meet some educators. I'm inviting principals and teachers from around the district, and I'm not sure who's going to come, but and then I'll also have some parents and kids. Right, so, oh, and I have a gal from NASA. She teaches with NASA, and she's going to come and do a talk too. She might have a booth. Okay, free to join, free to exhibit. There's the QR codes on it, and I'll send it in the RSSC email. Okay? I really appreciate the opportunity to share this with you guys. This is all part of my bigger goal for the future. I'm trying to narrow down the things that I do. I don't do it very well, but I'm still, it's narrower than it was before.
Sure. Thank you, Trish. I might be able to, I'll ask see if everyone wants to go. Okay, so then last but not least, Alan.
Oh, all right. Okay, I'll make this quick. Go ahead and share my screen. Window. There's Windows the charm. Okay. All right. Start off quick plug for our RSSC list group on Google. Hopefully everyone has already joined. And if you haven't, this is where we have most of our conversations. So you have the option of getting emails as conversations happen or daily or weekly digests. It's a great way to keep in touch. One of our more recent conversations was about a new product coming out from Unitree. A year ago, they came out with a $2,400 quadruped, which was a great deal. Now they're advertising a $1,600 quadruped that starts at $1,600. Looking at their promo video, let me go ahead and share this with sound and video. Their promo video is really slick.
Yeah.
And
I'm back.
Welcome home.
Good boy. Shake hand. Very good. Give me some water.
Sorry, I can't reach it. I'll dance to pleasure you instead.
Nice dance. Now, take a photo of my outfit.
As you wish. Cheers.
Beautiful. Let's go out for a walk.
all right, so
Looking at the photo pleasure line.
so it is a super cool platform, and much like when the Olive Run Robotics Pepper came out at $2,500, quote unquote, my first thought was sign me up, I'll take two. And in the Pepper's case, it was $2,400 to get it shipped to you, and then a multi-year $600 a month support plan. So obviously I didn't buy any of it. So now this one came out. They're advertising it at $1,600. It's the newer version of the Go1. It's got this LiDAR. It looks slick. And for a moment, I'm like, you know what? Sign me up for two. That sounds incredible.
True, wow.
Sure, one for upstairs and one for downstairs. Although
Right,
you have
upstairs.
so yeah. And when you look for their Go1, they have an SDK and ROS compatibility. I started to get really excited. But then the devil's in the details. The way they market and segment their product line is their lower two, the Go2 Air, which is this one, and the Go2 Pro, they're basically radio controlled toys. You can't program them. You have to have the educational version, which starts at like 14 grand, where they graciously unlock the SDK for you to dabble in. And so that was the first barrier.
Big barrier.
Yeah. The second one is that you can't get this for $1,600. Sure,
No,
they
that's the
advertise it for $1,600.
That's like the.
However,
bonus
yep,
price.
you've got to, because shipping to the US, they have to charge a 25% duty, which is 100% our fault. And
That's
then,
US policy.
yeah, and then shipping
300,
is,
that's $400 per.
yeah, and then shipping is $400 per unit. So to get the cheap one without programming would be a minimum
$2,500?
$2,400. Yeah. So that's a bit of a bummer. Now, on the upside, because of the Go1, there's this home brew group of folks that are like, that doesn't seem fair. So they reverse engineered their SDK and published their own version of it that doesn't have the restrictions on it. So for the Go1, you can use the FreeDog SDK to do all the same stuff, which is really cool. And if you look on their Slack, which is linked to, they're chomping at the bit to get a hold of a Go2 to be able to crack it and reverse engineer it like the other ones. So I remain hopeful that as they release the Go2, these guys will be able to hack it. The thing is, all these quadrupeds are based on the same MIT Cheetah design and code base. So when they dug into the Go1, they're like, yeah, this is 80% Cheetah code, right? Which is, okay. They're continuing to come down in price, and also they link to a whole bunch of developer documentation on the Go1. So I'm expecting a similar amount of interest once the Go2 is released later this year. So I think where I'm drawing my line in the sand is $2,400 for a radio-controlled dog is not my cup of tea. However, if it ever gets support from the open source SDK and I can find it for $1,600, that might be a fun thing to hack.
That's less
until
than
then.
powerful computer.
Yeah.
With the GPU, like my AI, whatever, our computing costs are well above that for server.
Yeah, heck, there are smartphones out that cost more than that right now.
Oh, yeah.
So.
Well, that's an average computer.
Yeah, and so the YouTube clip, which none of it's rendered, it's 100% real
that
product.
looks fake.
But it is cherry picked, and a lot of those features are only available at the pro level or at the edgy level. So the Air one, the $1,600 one, won't even follow you. That's only available in $2,800 pro version.
No, you said the Cheetah is based on Cheetah software, but that software is open source. The Cheetah, so they can. Oh, but the MIT license allows them to use it in commercial products. Yeah. So,
which is fine.
But actually that helps the reverse engineer errors, right? Because it's mostly open source code, so.
Yeah.
They just have to reverse engineer the non-open source code.
Yeah, so I'll keep tabs on it, and I'll let you guys know in the forums as that progresses. But just like Pepper, it gets you super excited, a robot in every home, and they're like, no, not really. Review semester right.
It's got all the mechanicals worked out. That's nice.
Yeah, that's incredible.
Yeah, it's a great platform for the price, but just to be able to drive around is a bit exciting.
Yeah. Well, the same with Spot. Well, if you had a lot more money and you wanted to buy a Spot for 80, 90, 100.
Now that one,
100 grand.
90, 70 or something, yeah.
But then with Spot even, it comes with a remote control, and but I'm not sure. Well, you have to have a service contract, I think, too.
Well, that much, I would hope so, yeah.
And then to program it, I think you can program it though. If you buy $100,000 Spot, you can program it.
Yeah, I don't remember the tiered pricing for Spot. I think it was once you got it, you have access to. Like these guys are like, $1,600. If you want to program it, get the edgy version for 14 grand.
That's milking from the poor educators.
Yeah.
That's pretty lame. It should be the other way. Like Steve Jobs' model. Give things to the education, then you get employees back, make the corporate people pay the high price. That's generally what you do. They write it off. It's part of it. Education people have no money.
What? Cash in that sweet grant money.
Oh. Sorry, I'm well,
No, you're
actually, I'm on
absolutely
your
right.
side, right?
Yeah,
You would probably argue.
you're right.
I don't work for education, so I can't claim, but.
So, yeah, my hopes were dashed, but.
Yeah, it was a brief, see, I tend to read those after you've already gone through your roller coaster emotion. I'm like, oh, I'll just skip. It's like, okay, well, another one that won't be getting any time soon.
Yeah.
I'm still gonna build my $110 quadruped made out of like little chiclet plastic and just to see it move its little legs, well, there's a few people that got it to walk backwards. It walks backwards better than forwards, but I don't care. Turn the thing around. Who cares?
Head on the other
Put the
side.
head on the other side.
Yeah. Oh, that's a feature. This is the Freenove. I'm talking about the Freenove quadruped.
Oh, I thought you were talking about the biddle, the kitty, the robot kitty.
No, the Freenove one that the HBRC people have been building.
Oh, okay.
I bought one. It takes about 6 hours to build it apparently, but I haven't. I need to do that. It's very limited for $120. But at least you get the idea of what a quadruped is like and all the pieces that are necessary and the control of it, essential, and you can code it. But yeah, you have to start somewhere if you want to. I wouldn't take like Chris Albertson's approach, where I'm going to build one from scratch. Is the first thing I do, and spend a year or more. I mean, it's great. I admire that. But
I've designed 3 so far. I only finished.
Yeah, you've been doing it.
Yeah.
Oh, you had quadrupeds too, or
Yeah. Remember what's his face? Todd the Quad.
Oh, I thought Todd was a quad.
Todd was a quad.
Why did I think he was something else? It's in the name. Right. Yeah, Todd the Quad. Right. Yeah. And then you've done a couple other ones too.
Yeah, there was a Spot Nano that had the spot orientation form.
What that little standing there that you got your
Oh, Pepito.
That's Pepito. Pepito's a biped.
And then Pepe, yeah.
Is he bipedal? Yeah.
But the thing with yours is that, like for these guys, they're big. You went the other way. How small can I make this?
Go small or go home.
Yeah, you went small, right? And that Freenove is just a pretty small one too, a little bigger than. Yeah. It can be fun to design, but yeah, I'd like to just put together a kit and see if I like quadrupeds at all, and then I always seem to want to do kits first. Some people, a lot of people design first, or make it from scratch. Like Dr. Bruce did all his robots from scratch pretty much, except until he got to the Zentech stuff. I don't have that kind of vision.
Thank you, Alan.
All right.
That was the last show and tell, so I guess you can stop the recording, and we'll call it a meeting. Thank you, everybody, for